I just introduced a few aspects. Okay, so now I'm going to carry on, right, with the calculation of probability. Now, if you want to calculate the probability, the first thing, okay, and identify your event. Okay, generally, an event is denoted by a capital letter E. Okay, an event is denoted by a capital letter E. So any event that you might think of, either it's rolling a dice, or it's tossing a coin, or it's picking a specific type of card from a deck of cards, and so on. So all those different types of possible outcomes, you can represent them by a capital letter E. Okay? E. Please be aware that we can use any other letter, but I'm going to use the capital letter E up to metric, because next year we'll also do grade 12 probability. Okay, so our event, we are going to represent it by a capital letter E. Then our sample space, we are going to represent it by a capital letter S. Okay, so in probability, if you want to calculate the probability of any event, it's always equal to, well, I prefer the number of favorable outcomes divided by the number of all possible outcomes. The number of all possible outcomes, that's your sample space. This is the number of all, okay, let me put an N in front there. So we can say NS. When I say NS like that, it means the total number of all the possible outcomes. Then, if I say NE like that, that's the number of your favorable outcomes. Okay, so using probability notation, the probability, okay, which is denoted by a capital letter P, then you put the event inside brackets, whichever event you are talking about. So our event is E there. If you're trying to get a tail or a head after tossing a coin, then you could say PT or PH. Okay? If you're trying to get a 1 or a 2 after rolling a dice, then you can say P1 or P2, P3, P4, P6. Okay? Right? So this is equal to NE, which is the number of favorable outcomes, divided by the total number in the sample space. That is the number of all possible outcomes. So this is the general formula for calculating probabilities, if you are using probability notation. So if you hear me saying NS, I'm referring to the total in the sample space. Okay? Please, you need to get used to this notation, especially if you are in this class, because you need to know when you're writing a test, let the examiner ask themselves what is the learner trying to write, because you know your stuff. The quality of your work must be of a higher standard. Okay, so the probability of any event is equal to the number of favorable outcomes, that is NE, divided by the total in the sample space. Okay, remember the total in the sample space is the number of all the possible outcomes of that specific event. Right? Now, when you do a calculation of probability, your answer must never be negative. It must be between -1 and, so it must be between 0 and 1. Okay? Or you can say it must be between 0% and 100%. Okay? But I don't like to write probabilities as a percentage. I prefer to write them between 0 and 1, that is as common fractions or decimal fractions. Okay? So in probability, there are no negative answers. So in this topic, until we finish doing the grade 11, you don't get negative answers. It's all positive answers throughout. Okay? So this is also important for you to know. All right? Then let's carry on. Can I move on? Okay, we've got a simple example there. Okay, so a fair dice is rolled once. What do you think the word fair means?
There's an equal chance of each.
Yeah. It means there is an equal chance of getting any of the 6 outcomes. It means it's probably a perfect cube. Okay, so it is rolled once. List the elements of the sample space. Now, when you are writing that, the proper way to write it is like this. So, to be the problem here. Okay. Okay, so if you want to list all the elements in the sample space, then you write S is equal to, okay, the first one has to be a 1, then a 2, a 3, a 4, a 5, or a 6. Okay, so that's a subset. We can call it a subset if you want. Right? Then the first question, so this is 1A, then 1B. 1B, what is the probability that you get a 6?
1 over 6.
So this would be P, a 6. Okay? Now a 6 is our event. So there's only one, so it will be 1 over 6. So this is then P, an odd number. Okay, so we've got a 1, a 3, and a 5. So that will be 3 over 6, which is a half. Okay, the probability of getting a 7, probability of getting a 7 will be 0. So P7, that will be 0. Okay, because on the dice there is no 7. Okay, then more than 2. More than 2. So the probability of getting more than 2, okay, that will be 4 over 6, which is 2 over 3. You can't get an answer which is more than 1. Less than 10? 1. So P less than 10. That would be 6 over 6, which is the 1. Okay, so this is very simple, by the way. It's more like we are doing grade 8 and 9 work here. We are not in grade 10 yet. Okay, let's move on to, okay, so far, what we are doing here, the probability that we are trying to calculate, it's called a theoretical probability, which is the most common one that you are going to encounter. Okay, so whenever you calculate a probability, it's called a theoretical probability. Right? Then you've got this one as well. So it says 6 counters in a bag are numbered 3, 4, 7, 9, 10, and 11. One counter is drawn at random from the bag. What does the sample space consist of? Okay, so your sample space. Okay, so the sample space is going to be made up of the 3, the 4, the 7, the 9, the 10, and 11. Okay? Then the next question says, calculate the probability that the number drawn is an odd number. So B1, so it would be P odd number. Okay. How many of them are odd numbers? So that will be 4 over 6, which is 2 over 3. So this is very straightforward. A prime number.
One of the things that
Will you stop?
is
What is a prime number?
not the number that we have to balance.
Okay, is 3 a prime number?
Yes.
A 4?
No.
7?
Yes.
A 9?
No.
10?
No.
11?
Yes.
So how many prime numbers?
One of the three.
So it's a 3. So prime number. Okay, this is very simple, by the way. You are most likely to not get questions like this. Right? Then a square number. How many square numbers do you have? Huh?
Yeah, this is one of the three.
Which square numbers do we have?
4, 9.
So that will be P square number. So that will be 2 over 6, which is a third. Well, this is very simple. Okay, please be aware that these type of questions are very, very easy. You are most likely to not get questions like this. It's more like division of grade 8 and 9, maybe grade 7. Okay, so let's talk about relative frequency. Now, your relative frequency is also called experimental probability. Now, this one, you can only get it if you do an experiment. And usually the experiment must have many trials. Okay, you must do, if you carry out an experiment and you have got many trials, or if you do a survey which consists of a very large sample, then you estimate the probability. That is called the relative frequency. So relative frequency is an estimated probability. It's not the calculated one. Okay? So theoretical probability, you get it by calculation. Relative frequency, you have to carry out an experiment which involves a large number of trials or a large sample. Then you estimate the probability of that specific event. Okay? So you can read here. But for your curriculum, you are going to encounter theoretical probability more than relative frequency. Okay? Your curriculum does not focus more on relative frequency, it's mainly theoretical probability. Okay, so what I'm going to do